Okay. Today we are going to cover the topics. First, we will see micro machining. Then we will see CNC, that is computerized numerical control machine, and IoT, that is Internet of Things. Okay. I hope screen is visible and I am also audible. Please acknowledge. Yes. In advanced manufacturing processes, we are going to start first is the micro machining. What is micro machining? माइक्रो मीन्स व्हाट? आप लोगों को पता होगा माइक्रो मीन्स व्हाट? 1000 part of the millimeter, right? At micro level, जैसे यूनिट होते हैं मीटर, मिलीमीटर, माइक्रोमीटर, right? That is nothing but micro means at that small dimension, and doing the machining at that small diameter, that is nothing but your micro machining. Suppose I want to take the whole of 20 microns. Can I take it with our conventional drill bit? Is it possible to take whole? If suppose I want a surface finish of up to 10 micron, or up to 30 micron, or up to 500 micron, then it is not possible with conventional machining. That's why this is advanced manufacturing processes we are using, right? Now, in straight words, micro machining means machining done at the micro level, or chips or debris that we are removing, that is at the micro level. That is nothing but micro machining. Now, in order to do that micro machining, various techniques we are using. As per these techniques, various types of micro machinings are there, right? We are using laser light, we are using concentrated light, we are using abrasive jets, right? We are using electron discharge machining. So these are the various methods by which we are able to do the micro machining, right? Now here you can see what is micro machining. Removal of material in the form of chips or debris having the size in the range of microns, right? So whatever the chips or material that we are removing, uska size from 10 microns to 999 microns. From 10 microns to 999 microns, right? That is nothing but micro machining. Okay. Now creating the micro features of surface characteristics, especially surface finish in the micro or nano level. For this, micro machining is useful. Now definition is what? Material removal at micro or nano level with no constraint on the size of the component being machined. That is nothing but your micro machine. माइक्रो मशीनिंग की डेफिनेशन समझ में आई? Yes. Now the term micro machining usually refers to the fabrication of micromechanical structure with the aid of etching technique. Etching means what? Removing in small particles. That is nothing but your etching, right? To remove the part of the substrate or a thin film. Micro machining में जो technique use होती है, that is etching. Etching means what? Removing the material in the small quantity. Then next point is silicon. Silicon has the excellent mechanical properties, making it the ideal material for machining. Okay, because of silicon's material properties, it is used most of the times it is used in the micro machining. Now, micro machining usually refers to the fabrication process of MEMS, means micro electromechanical systems. Now, this micro machining is required in the small electronic parts, right? But machining is the mechanical process. So this mechanical process we are using in the small electronics parts. That's why this is totally termed as MEMS, micro electromechanical systems. In that, micro sensors and microstructures in the general. You might have heard the terms microcontroller and all this. These are also manufactured with the help of micro machine. Now, these are the different techniques by which we can able to do the micro machining. First is the photolithography. Photo means light. In this, we are using the lights. Etching means removing in the small part. Silicon micro machining, Liga, mechanical micro machining. These are the various types, out of which we will see first one and another one, that is jet machining. Here you can see photolithography. This is one type of micro machining. Now, photo means light, right? Now, how we are using the light to remove the material, right? You can see here, this is your light source. That light source is allowed to pass through this condenser lens. Okay, in this condenser lens, your light will be lighted from whatever the light is coming from source, that is scattered one. Now, because of this condenser lens or glass lens, your light will convert into the straight line. Okay, when your light will be passing through the this mask or rectile, and then what will happen, whatever the light coming out from this rectile, when it is passing through the projection lens, in projection lens your light can be concentrated, right? So here it is concentrated at the foci, which is little above the surface, right? Now at the foci, the dimensions will be like a very small size dimension. Okay, लाइट वेव का लाइट्स के जो फोटॉन्स रहते हैं उसके डायमेंशन कितने छोटे रहते हैं, वेरी स्मॉल डायमेंशन, राइट? अगर तो इतने स्मॉल लेवल पे भी हम मशीनिंग कर सकते हैं. तो बाय यूजिंग दिस लाइट इफेक्ट we are just removing the small parts, small debris, and that is how the micro machining is done in the case of photolithography. Now you can see the steps involved in this. First one is the clean substrate. पहले हमें उसको clean करना पड़ेगा. Second, coat the substrate with 40 micrometer of lead. उस surface के ऊपर 40 micrometer lead apply करेंगे. उसके बाद we will dip this coat with photoresist material. At the top, photoresist material is added. Then expose with laser. Then that laser light will be fall on this. Wherever the laser light is fall here, you can see laser light is falling on this, right? Develop away unexposed resist. Then this unexposed resist material that will come out. Okay, then wet etching. At the last we will do the wet etching and we will get this component. That is how the photolithography is done here. Now, photolithography description, you can see here. The vapors are chemically cleaned to remove the particulate matter, organic, ionic, and metallic impurities. High-speed centrifugal whirling of silicon vapors known as spin coating produces a thin uniform layer of photoresist, a light-sensitive polymer on the vapors. Photoresist is exposed to a set of light through a mask often made of cords. Wavelength of light ranges from 300 to 500 nanometer UV rays, and X-rays wavelength is 4 to 50 angstroms. 1 angstrom means 10 raised to minus 10 meter. Angstrom is the unit of length of the wavelength of the light. Okay, two types of photoresist are used: positive, that is whatever shows and goes, and negative, whatever shows stays. You can see here same things, negative photoresist and positive photoresist. In negative photoresist, whatever is showing, that will stay, and in positive, whatever shows, that will go. And at the last, we are getting the etched patterns. Okay. Now next micro machining process is the abrasive jet materials. Now what is abrasive? Abrasive is nothing but small particles, very small and hard particles. Now what we will do with these hard particles, we will pass we will mix these hard particles with the air, and that air we will force to pass through a very small nozzle, right? When these small abrasives are passing through with this air, because of this air pressure, these abrasives are also flowing with very high speed, and when these abrasives are falling on any workpiece, then that then these abrasives will remove material from that, right? Now how it is, you can see here, in abrasive jet machining, a focused stream of abrasive particles carried by high pressure air or gas is made to impinge means falling on the work surface through a nozzle, and work material is removed by erosion by high velocity of abrasive particles, right? Now if suppose this is your nozzle, this is your nozzle, right? Now through this nozzle, your high velocity air is flowing. Now in here, along with here, there are some abrasives, right? So these abrasives will be allowed to fall on this workpiece. This is your workpiece, right? When these abrasives will fall on this workpiece, what will happen? Whatever the, because of high velocity of this material, here material will be removed from the workpiece, right? That is how this abrasive jet machining works. Okay. Then another one is method is also there, that is electron discharge machining. In electron discharge machining में क्या करते हैं हम, we are forcing the electrons to fall through the small nozzle on the workpiece. इलेक्ट्रॉन की साइज कितनी छोटी होती है, बहुत छोटी होती है, right? So electrons, because of fall of electrons at very high speed, it will take the small hole, or material will be removed at small scale, right? There are some holes which are in the nanometer or in the micrometer. So such holes can be taken with the help of micro machine. Additive manufacturing we have seen yesterday. That is how the micro machining. Okay. I hope you understood micro machining. Now next one is the CNC machine. What is meant by CNC? Can anyone tell me full form क्या है CNC का?
Computerized, numerically controlled.
Yes, CNC means computerized and numerically controlled machine. Okay. Now this CNC machine is same as that of lathe machine only. But हम lathe machine में क्या करते हैं? टूल को लोड करते हैं, वर्कपीस को लोड करते हैं, स्पीड कम ज्यादा करते हैं, टूल को मूव करते हैं. All these operations are carried out by operator in lathe machine, right? An operator is in touch with the machine. So if accident may happen in the machine. So in CNC machine, there is only lathe machine, but that lathe machine is operated with the help of computer. A small computer is there in the CNC machine. So we are operating that CNC machine with the help of computer. That's why it is called as computerized and numerical controlled machine. Okay. Now in this, spindle ka speed, when that spindle or this jaw will hold the workpiece, at what speed workpiece will rotate, which tool will be selected, movement of the tool, everything is controlled by centralized computer or microcontroller or machine control unit, हम उसको machine control unit बोलते हैं, right? So that will control all the things. Now you can see here the use of computers to control machine tools like lathe, milling, shaper, etc. is called as CNC machine. So CNC machine में सिर्फ lathe नहीं होती, lathe machine, milling machine, drilling machine, shaper machine, all these, whatever the operations we are conventionally carried out on all these machines, all these operations will be carried out on CNC, but with the help of programming, right? Now, the operations which can be carried out by CNC machines are mounting the job or machine rotation of spindle. So अब सपोज वी विल, हम लेथ मशीन का एग्जांपल लेंगे। लेथ मशीन में क्या क्या करना पड़ता है? माउंटिंग ऑफ जॉब और मशीन, रोटेशन ऑफ स्पिंडल, मूवमेंट ऑफ ऑपरेशन ऑफ डिफरेंट टूल्स इन सीक्वेंस, राइट? एक एक वर्कपीस के ऊपर या एक जॉब के ऊपर सिर्फ एक ऑपरेशन कैरी आउट नहीं होता, अलग अलग ऑपरेशंस कैरी आउट होते हैं, राइट? डिपेंडिंग ऑन द जॉब कैसे बनाना है हमको और कौन से टाइप का जॉब है। So requirements of job, tool changing, on and off operations, and releasing the finishing job. All these operations will be carried out with the help of machine control unit. And these machine control units will be fed with the help of input programs, part programs, or codes. So these codes will take care of all these operations. Okay. Now for the operations as mentioned above, a program is done on a tape and fed to the machine through computer. Okay, so sometimes in olden days we used to do the program on tape. Tape आपने सुना होगा, old cassette में जो stick रहते हैं ना, that magnetic strip, that is nothing but your tape. So उस tape के अंदर प्रोग्राम करके वो tape हम in the form of CD और DVD मशीन के अंदर इंसर्ट कर देते थे। So मशीन वहां से इंस्ट्रक्शन लेके ऑपरेट करता था। लेकिन nowadays we are using pen drive or we are also using the Wi-Fi. Through Wi-Fi also we can transfer all these things. हमने एडिटिव मैन्युफैक्चरिंग या 3D प्रिंटिंग में देखा है, कैड मॉडल बनाते हैं, वैसे सीएनसी अभी एडवांस्ड सीएनसी मशीन में भी हम ये सारी चीजें कर सकते हैं। Now this method helps to change the program if required with minimum time and cost. Yes, ये सीएनसी मशीन है। तो आप देखो अंदर लेथ, अंदर देखोगे तो आपको पता चलेगा ये लेथ मशीन ही है। यहाँ पे आपका स्पिंडल है, चक है, चक के अंदर हम जॉब फिक्स करते हैं, ये टूल पोस्ट है, राइट? ये टूल आपका लेथ मशीन का बेड है, ये डोर है बाहर का, जो ये नीले कलर का है ना, ब्लू कलर का, दैट इज डोर। वंस योर job is inserted there, you just close the door and start the machine. So machine will automatically operate. आप बाहर से देख भी सकते हो। और ये आपका मशीन कंट्रोल यूनिट है, कंप्यूटर है ये आपका। सो ये जो कीबोर्ड आप देख रहे हैं, वहां से आप इनपुट दे सकते हैं और इनपुट देके और ये स्क्रीन के ऊपर डिस्प्ले हो जाएगा कौन सा ऑपरेशन चल रहा है, कैसे चल रहा है, कब तक आ रहा है, कितना टाइम रिमेनिंग है, एंड ऑल दिस विल बी कंट्रोल्ड विद द हेल्प ऑफ मशीन कंट्रोल यूनिट। नाउ मशीन कंट्रोल यूनिट क्या करेगा? इनपुट इंस्ट्रक्शन लेगा थ्रू द कीबोर्ड और थ्रू द सीडी डीवीडी। उसके अंदर क्या होगा? प्रोग्राम होगा। कौन सा प्रोग्राम? हमें टर्निंग ऑपरेशन करना है, तो एक एंड से दूसरे एंड तक योर टूल विल मूव. So this x-axis, origin axis will be decided, and accordingly your tool will move, right? And with the help of feedback system, your machine control unit will take input instruction. It will also take feedback with the help of sensors, and accordingly it will give the command to the actuators. Actuators में क्या क्या आएगा? Chuck, rotation of chuck, start and stop of spindle, then movement of tool, then motion of tool, speed of the spindle, right? Coolant on off, all these operations will be taken care with the help of program. उसके लिए अलग अलग codes है, G codes और M codes. Now in coming slides we will see all this. So this is your CNC machine. So in exam there will be a question, write a short note on CNC machine. तो उसमें आप CNC मशीन की बेसिक इंफॉर्मेशन लिखना है, उसके बाद ब्लॉक डायग्राम निकालना है, राइट. सो पहले हम वो सारी एक्चुअली पूरा खत्म करेंगे, बाद में क्वेश्चन डिस्कस करेंगे. यस, ब्लॉक डायग्राम ऑफ CNC मशीन. Here you can see block diagram. The central part is the MCU. What is MCU? What is MCU? Tell me what is MCU. अभी बताया ना मैंने 2-3 बार.
Machine control unit.
Yes, right. It is machine control unit. Machine control unit means one type of computer. That is your microcontroller, microprocessor and microcontroller. ये यूनिट रहते हैं, राइट. और उसके अंदर देखो इनपुट डिवाइसेस. इन इनपुट डिवाइसेस देयर विल बी अ कीबोर्ड, CD, DVD, पेन ड्राइव, राइट. उसमें क्या रहेगा? प्रोग्राम्स रहेंगे, पार्ट प्रोग्राम्स. ओके. नाउ इन मशीन कंट्रोल यूनिट देयर इज अ data processing unit, that is your microprocessor, and control loop unit, that is your microcontroller. Okay. And one display unit is also there. So whatever operation is going on, that will be displayed, or whatever the instructions are required from the keyboard, that instructions will be displayed, and accordingly your operator will press the buttons. Okay. Now microprocessor क्या करेगा? ये प्रोग्राम रीड करेगा, अकॉर्डिंग टू प्रोग्राम कंट्रोल लूप को सिग्नल देगा. कंट्रोल लूप क्या करेगा? whatever the एक्चुएटर्स है, मतलब स्पिंडल को रोटेट करने के लिए क्या एक्चुएटर है? मोटर है. टूल को मूवमेंट करने के लिए क्या? हाइड्रोलिक यूनिट है. सो उस हाइड्रोलिक यूनिट को क्या देगा? वो एक्शन देगा, राइट. So as per this your spindle will start rotating, your tool will start moving, and for this वो tool कहाँ से कहाँ तक move होगा, वो spindle को कितना speed चाहिए, वो सब program में लिखा होता है. Okay. So that instructions will be given to the machine's tool. So accordingly your machine's tools will move. Machine's tools कौन कौन से? Rotation of spindle, movement of tool. Okay. Then your driving system में क्या क्या आता है? Your motor and all this. And one more system is their feedback system. Now there are various sensors which are located at the machine's tools. Now where is the position of machine's tool? So feedback system का काम क्या है? As per program, whether your machine tool is there at this position or not. So ये feedback system sensor से वो data लेता है, and this data will be fed back to the your machine control unit. Okay. So there will be a position sensor, velocity sensor. As per that, where is the position of tool, what is the velocity of your spindle, all this data will be transferred here. If this is not as per the program, then your machine will stop, and it will give the instructions to the operator that you need to make some changes because your machine is not working as per the program, or automatically it will change the position and speed of the sensors and machine tools. That is the function of feedback system. So ये ब्लॉक, आपको ये ब्लॉक डायग्राम ड्रॉ करके इनपुट डिवाइसेस का फंक्शन क्या है, पार्ट प्रोग्राम में क्या होता है, मशीन कंट्रोल यूनिट का क्या फंक्शन होता है, उसके अंदर क्या क्या होता है, देन मशीन टूल को सिग्नल कौन कौन देता है, फीडबैक सिस्टम क्या होती है, उसका फंक्शन क्या होता है, ऑल दिस थिंग्स यू नीड टू एक्सप्लेन. समझ में आया आपको? ये ब्लॉक डायग्राम ऑफ CNC. इनपुट डिवाइसेस से इंस्ट्रक्शन लेगा machine control, right, in the form of programs under machine control. In machine control unit there is a microprocessor and microcontroller. So it will process all the information taken, right, and accordingly it will give the instructions to the actuators, or to, that is nothing but your driving system, electric motor, मशीन टूल्स में क्या क्या आएगा, योर स्पिंडल टूल, और फीडबैक सिस्टम क्या करेगा, फीडबैक देगा, जो करंट वर्किंग शुरू है उसका फीडबैक देगा, किसको, मशीन कंट्रोल यूनिट को, right? And as per this your operations will go on smoothly. And in display unit, whatever the operation is going on, that will be displayed on the display screen. That is how this CNC machine works. Yes. Yep. Okay, you can see here main parts of the first input devices. These are the devices which are used to input part program in the CNC machine. There are three commonly used input devices, and these are punch tape reader, magnetic tape reader, and computer via RS-232C communication. These are the olden devices by which we were taking the programs or data in tape reader and all this. Nowadays it can be taken with the help of your pen drive also. Okay, machine control unit. Okay, it is the heart of CNC. It is the heart of the CNC. It performs all the controlling action of the CNC machine of the various functions performed by the MCU. It reads coded instructions fed into it. It decodes coded instruction. It implements interpolation, that is linear, circular, and helical, to generalize axis motion commands, right? So इसके अंदर भी मैथमेटिक्स की ही होता है. So it feeds the axis motion commands to the amplifier circuits for driving the axis mechanisms. Okay, it receives the feedback signal of position and speed for each drive axis. It implements the auxiliary control functions such as coolant or spindle on off and tool. Coolant क्यों लगता है? Because during some of the operation lots of heat is generated. So to avoid overheating of the tool and overheating of the workpiece, so coolant is used. Okay, next is the machine tool. Now in machine tool, a CNC machine tool always has a slide table and a spindle to control on the position and speed. In CNC लेथ मशीन में क्या क्या कंट्रोल करना पड़ता है हमको, स्पिंडल का स्पीड, टूल कौन सा यूज करना है या टूल चेंज, और वो टूल चेंज की सीक्वेंस, और मूवमेंट ऑफ द टूल एंड पोजीशन ऑफ द टूल. All these things are there in the machine tool. Okay, so machine table is controlled in x and y axis direction, and the spindle is controlled in z axis direction. Yes. Then driving system. The driving system of CNC machine consists of amplifier circuit, drive motors, and ball lead screw. Okay, the MCU feeds the signal, that is position and speed, of each axis of the amplifier circuit. The control signals are then augmented, increased to accurate the drive motors, and the actuated driver motors rotate the ball lead screw to position the machine table. Feedback system. This system consists of transducers that acts like sensors. It is also called as measuring system. Feedback system is nothing but your feedback. आपको जैसे आप फीडबैक देते हो ना फैकल्टी का, सेम तरह से फीडबैक सिस्टम होती है. ओके, in order to make the corrections. It contains position and speed transducers that continuously monitor the position and speed of the cutting tool located at any instant. The machine control unit receives the signal from these transducers, and it uses the difference between the reference signals and feedback signals to generate the control signals for correcting the position and speed errors. Display unit. In display unit, a monitor is used to display the programs, commands, and other useful data of CNC machine. Yes. How CNC is working, already that we have explained. It is taking instruction from the input, then it is processing and giving command to the driving system and machines tools, and feedback system is used to check whether everything is working as per the given instructions or not. right? That is your working of CNC machine. समझ में आ रहा है ना मैं क्या एक्सप्लेन कर रहा हूँ, या पूरा ऊपर ऊपर से जा रहा है? एटलीस्ट 50-60% तो समझ में आ रहा है ना? Hello.
Yes, sir.
Okay, thank you. Yes. Now advantages of CNC machines. Already we have discussed the advantages. Now here we will see one by one, we will see the advantages. First, it can produce jobs with the highest accuracy and precision than any other manual machine. Accuracy बहुत high होती है CNC machine के अंदर, क्योंकि सब कुछ is programmed. Human error के लिए कोई chance ही नहीं उसमें. Okay. Now second, it can run for 24 hours a day. एक बार प्रोग्राम फीड किया तो continuously it can keep on working. Third, the part produced by it have the same accuracy. There is no variation in the parts manufactured by the CNC machine. अब मैन्युअली ऑपरेटेड लेथ मशीन में क्या होगा, अगर वर्कर सुबह सुबह काम कर रहा है तो फ्रेश है तो एक्यूरेसी ज्यादा रहेगी, दोपहर में फिर खाना खाने के बाद एक्यूरेसी कम हो जाएगी क्योंकि ऑपरेटर लेजी बन जाएगा. लेकिन मशीन के बारे में ऐसा कुछ है क्या? नहीं. 24 आवर्स, सेम मूड, सेम फ्रीक्वेंसी, सेम वर्किंग. सो जितने भी हम कंपोनेंट बनाते हैं उसके अंदर सेम एक्यूरेसी रहती है. Then highly skilled operator is not required. Actually, for operation, highly skilled operator is not required, but to create the program, highly intelligent person is required. To operate, highly skilled worker is not required. लेकिन लेथ मशीन ऑपरेट करने के लिए स्किल्ड वर्कर चाहिए. लेकिन सीएनसी को सिर्फ उसको थोड़ा सा इंस्ट्रक्शन देना है, ये ऐसे करना है, वो ऐसे करना है. लेकिन लेथ मशीन के अंदर हमेशा वो वर्कर जागरूक ही रहना चाहिए, नहीं तो एक्सीडेंट में हैपन और योर एक्यूरेसी में डैमेज, राइट? बट सच थिंग्स आर नॉट हैपनिंग इन द CNC machine. Or a semi-skilled operator can also operate accurately and more precisely. Then next advantage, operators can easily make changes and improvements and reduces the delay time. Okay. Then it has the capability to produce complex designs with high accuracy in minimum possible time. Okay. The modern design software allows the designer to simulate the manufacturer of his her idea, and this removes the need of making a prototype or model and saves time and money. Few workers are required to operate CNC machine and save labor cost. So number of workers are also required less, so it saves the labor cost. Now disadvantages. What are the disadvantages? First, the cost of the CNC machine is very high as compared to manually operated machine. Initial cost बहुत है because बहुत सारे टेक्निकल कंपोनेंट्स है, एक्चुएटर्स है, फीडबैक सिस्टम है, कंप्यूटर है एंड हाइड्रोलिक सिस्टम है. ये सारे कंपोनेंट्स की कॉस्ट बहुत हाई होती है एज कंपेयर टू लेथ मशीन और मैन्युअली ऑपरेटेड मशीन. द पार्ट्स ऑफ द CNC machines are expensive. The maintenance cost is also high, and it does not eliminate the need of costly tools. So cost is the disadvantages. Now there are classification of CNC controlled systems. Now according to the operations carried out, the systems are classified as, first is the point to point system. Now in point to point system क्या करते हैं हम? It moves from point to point. Suppose CNC ड्रिलिंग मशीन है और मुझको यहाँ एक होल लेना है, यहाँ एक लेना है और यहाँ एक लेना है. So it just checking the point to point. So it first takes this point, then this point, then this point. Okay. So how this is taking this point? So this will be considered as origin, that is 0, 0. With respect to origin, what is the location of this? Suppose 5,3. Then it will go to 5,3 and will take hole. Then with respect to origin, इसका लोकेशन क्या है? 10,6. So वहां पे टूल जाएगा, होल लेगा, फिर ऊपर आएगा, फिर वहां पे मूव होगा as per their location. That is your point to point system. Okay. Then next one is the straight cut system. Now in straight cut system, your machine is taking the straight cut. Okay, in the coming slide I will show you straight cut. And in continuous path system, it is moving continuously, maybe like this in any given contour shapes. Okay, okay, you can see here. First one is your point to point system, that is used to take the holes at different locations. First one is the continuous cutting or straight line cutting, that is your second. And fourth one is the your this is straight line cut, and this is your continuous movement. Okay, yes. Now in CNC programs, okay, now in CNC program, the most commonly used codes when programming CNC machines tools are G codes, which are also called as preparatory functions, and M codes, which are called as miscellaneous functions. So CNC मशीन के अंदर दो कोड्स है, G कोड्स एंड M कोड्स. G कोड्स को हम प्रिपरेटरी फंक्शंस बोलते हैं और M कोड्स को miscellaneous function बोलते हैं. ये both codes we are using to give the instructions to the controller, machine control unit. Okay, other codes are also there, but mainly G codes and M codes are important. So what are G codes? Are sometimes called as cycle codes because they refer to some action occurring on the X, Y, and Z axis of the machine. And M codes or miscellaneous codes are used to either turn on or off different functions which control certain machine tool operations. So there are certain M codes and G codes. वो आपको याद रखना है. यहाँ पे देखो G codes G00. Now these G codes are always with 2 digits. Now first is G00, that is for rapid traverse. G01, that is for linear interpolation, to move linearly. G02 is for circular interpolation, to move circular, maybe clockwise or maybe anti-clockwise, right? G02 is for circular interpolation in clockwise direction, and G03 is for circular interpolation in anti-clockwise direction. Similarly, other G codes are also there. These are the G codes that you can refer. Okay, G002 to G91. Various codes are there, out of which important codes are given here. You can go through all these important codes. Okay, you can see here G00 क्या है? Rapid positioning. G01 linear interpolation. G02 circular interpolation clockwise. G03 circular interpolation anti-clockwise. G20 inch input. G21 metric input. G24 radius programming. G28 return to reference point. G29 return from reference point. G32 thread cutting. G40 cutter compensation cancel. G41 cutter compensation left. G42 cutter compensation right. G43 tool length compensation positive direction. 44 tool length compensation negative direction. 49 tool length compensation cancel. 84 canned turning cycles. G90 absolute programming and G91 incremental programming. Absolute programming means what? एब्सोल्यूट एंड इंक्रीमेंट प्रोग्रामिंग के बारे में, सपोज दिस इज योर वर्क पीस. एब्सोल्यूट प्रोग्रामिंग में जब फर्स्ट पोजीशन से सेकंड पोजीशन जाता है तो वो रेफरेंस किसका लेगा? ओरिजिन का ही लेगा. एंड इन इंक्रीमेंटल प्रोग्रामिंग ये फर्स्ट पोजीशन में जाएगा, फर्स्ट पोजीशन से सेकंड पोजीशन जाएगा तो रेफरेंस इस पोजीशन का लेगा, ओरिजिन का नहीं लेगा. दैट इज योर एब्सोल्यूट एंड इंक्रीमेंटल प्रोग्रामिंग. Yes. Now there are M codes, miscellaneous codes. So there are some M codes which are given here. You can see here direction of rotation of tool clockwise M03, M04 direction of rotation counterclockwise, tool change with automatic retraction, M30 end of program and return to beginning of the program. Okay. These are the various EM codes. You can go through this. Okay. You may think, sir, whether we need to remember all the codes or not. Whatever you can able to remember, you can remember. Okay. Now the last point is Internet of Things. आप लोगों ने सुना होगा Internet of Things. क्या है Internet of Things? Can anyone tell me? I would like to know what you know about IoT, Internet of Things. इंडस्ट्रियल रिवॉल्यूशन सुना है क्या? इंडस्ट्रियल रिवॉल्यूशन 1.0, 2.0, 3.0, 4.0. करंटली कौन सा इंडस्ट्रियल रिवॉल्यूशन चल रहा है? करंटली कौन सा इंडस्ट्रियल रिवॉल्यूशन चल रहा है? 3.0 और 4.0? इंडस्ट्रियल रिवॉल्यूशन कौन सा चल रहा है?
4.2.
4.0, राइट? सो इंडस्ट्रियल रिवॉल्यूशन क्या है, ये शॉर्ट में मैं बताता हूँ. इन द 18th century, around 1730, industrial revolution first started because of what? Steam engine. Okay. Then and 19th century, around 1920, around 1920, second industrial revolution started because of what? Electric motor. Okay. Around 1970, third industrial revolution started because of what? Electronics and computer. Okay. And around 2010, fourth industrial revolution started because of what? Automation, robotics, artificial intelligence. Okay. So this Internet of Things, that is nothing but your fourth industrial revolution. Okay. Now what is Internet of Things? आप इंटरनेट यूज करते हो मोबाइल के लिए, कंप्यूटर के लिए. That is also internet. So what is, there is one more thing, IIoT. IoT is what? Your Internet of Things. And IIoT, that is nothing but your industrial Internet of Things. Okay. Now what is industrial Internet of Things? इंडस्ट्री के अंदर जो हम इंटरनेट यूज करते हैं for the operation of machine, for the control of machine, for the connection of machine, for the repair of the machine, that is nothing but your IIoT, Industrial Internet of Things, right? अब इसके एडवांटेजेस क्या क्या है? यू कैन कनेक्ट एनी मशीन टू एनीवेयर. अगर एक कंपनी का प्लांट वेरियस लोकेशन पे है, so all these plants can be connected, all these machines can share information with each other through the network, through the internet. That is nothing but your industrial Internet of Things. Okay. Your machines can be made automatic, it can be controlled from distance. Okay. It now, a possible failure of the machine can also be detected with the help of internet. That is nothing but your IIoT, Internet of Things. ये उसके एडवांटेजेस है. डिसएडवांटेजेस क्या है? There are chances that your machine data may get public, right? प्राइवेसी कम है उस केस में, कॉस्ट थोड़ा ज्यादा है. ओके. यस. एंड इन केस ऑफ फेलियर ऑफ इंटरनेट, your machines may stop the working. Okay. So if there will be a question on Internet of Things, you will write the basic information, advantages, disadvantages, and applications. Okay. In SME, in most of the questions, basic information, block diagram, a given diagram, advantages, disadvantages, applications. These are the common things. Okay, so please keep your question answer in this format, depending on the, not for every question, but for the most of the questions. You can see that. Okay. Yes. Now working of IoT, and here you can see an IoT ecosystem consists of web-enabled smart devices that use embedded processors, sensors, and communication hardware to collect, send, and act on data they acquire from their environment. IoT devices share sensor data they collect by connecting an IoT gateway or other edge devices where data is either sent to the cloud to be analyzed or analyzed locally. Sometimes these devices communicate with each other related devices and act on the information they get from one another. The devices do not the devices do most of the work without human intervention. Although people can interact with the devices, for instance, to set them up, give them instructions to access the data. In IIoT, most of the machine work is done without human intervention. That's why labor force required is also very less. Okay, you can see here. So this sensor actuators data that will be taken with the help of internet, that will, according to that, your device will be operated. Gateway means what? Through which your data will be transferred, and your data will be stored in the cloud. Means if data is stored in the cloud, anybody can access from anywhere. That is nothing but your internet. You can see here basics of IoT: cloud, network, sensors, and all your analog word. That could be your temperature, pressure, position, weight, speed, flow, humidity, sound, light. That is your IoT. Okay. Okay, this is question bank. You can take the screenshot. I'm going to share this question bank of unit number 5. Okay. Now, okay, there are some points remaining, means that I will cover in shortly. Yes. व्हाइट बोर्ड कहाँ पे दिखता है, क्या देख लो आप. व्हाइट बोर्ड. Yes. We have started whiteboard. Yes. Last page. Please stop this whiteboard. I will share here from my side. Or okay. Now there is a one more system is there. I will tell this in shortly. That is your reconfigurable manufacturing system. Listen carefully. What is a reconfigurable manufacturing system? Okay. Reconfigurable manufacturing system. Now what is this reconfigurable manufacturing system? Now in reconfigurable manufacturing system, वो सिस्टम क्या होती है, हम रिकन्फ्यूग मीन्स मॉडिफाई कर सकते हैं सिस्टम, हमारी मैन्युफैक्चरिंग सिस्टम डिमांड के हिसाब से मॉडिफाई कर सकते हैं, उसको क्या बोलते हैं रिकन्फिगरेबल मैन्युफैक्चरिंग सिस्टम। अगर डिमांड ज्यादा है, हमको स्केल बढ़ाना है, तो हम बढ़ा सकते हैं, दैट इज नथिंग बट योर रिकन्फिगरेबल मैन्युफैक्चरिंग सिस्टम। ओके, ना उसके ना उसमें हम क्या क्या चेंजेस कर सकते हैं, स्ट्रक्चर में चेंज कर सकते हैं, हार्डवेयर कंपोनेंट्स चेंज कर सकते हैं, सॉफ्टवेयर कंपोनेंट्स चेंज कर सकते हैं। सो वो जो फ्लेक्सिबिलिटी है मैन्युफैक्चरिंग सिस्टम के अंदर, उसको बोलते हैं रिकन्फिगरेबल मैन्युफैक्चरिंग सिस्टम। ना उसके एडवांटेजेस क्या 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 है, वी कैन रिस्पॉन्ड quickly to the product demand. Okay, we can improve the productivity, we can avoid the obsolescence manufacturing system, right? और limitations क्या क्या है उसके, नाउ अगर स्केल बढ़ाते हैं तो समटाइम्स एक्यूरेसी कैन बी कॉम्प्रोमाइज्ड, दैट इज नथिंग बट योर रिकन्फिगरेबल मैन्युफैक्चरिंग सिस्टम। अगर क्वेश्चन पूछते हैं तो आपको पता होना चाहिए। और एक दैट इज योर एक्सट्रूजन सिस्टम। ओके, नाउ व्हाट इज एक्सट्रूजन सिस्टम? एक्सट्रूजन इज ऑल्सो फॉर्मिंग प्रोसेस। उसमें क्या करते हैं, यस, नाउ एक्सट्रूजन के अंदर क्या करते हैं हम, एक डक्टाइल मटेरियल इस डाई के अंदर रखते हैं, दिस इज व्हाट योर डक्टाइल मटेरियल। ओके, और इस डाई को हम यहाँ से एक स्मॉल ओपनिंग रखते हैं। ओके, एंड फ्रॉम दिस साइड यू कैन सी हियर, ये जो मैंने क्रॉस लाइन में बनाया ये क्या है, डाई है तुम्हारा डाई। ओके, और डाई के अंदर क्या रखा है हमने, ये व्हाट इज दिस, टेल मी व्हाट इज दिस, डक्टाइल मटेरियल है, और ये क्या है, ओपनिंग है। तो यहां से हम क्या करेंगे, रैम से इसको पुश करेंगे, इस डायरेक्शन में पुश करेंगे, तो क्या होगा, we will force this ductile material within this die, so this ductile material will start flowing plastically, right? तो क्या होगा उसका, so your ductile material, suppose this is your ductile material, okay, येलो कलर का डक्टाइल मटेरियल है, ओके, इसके अंदर डाई के अंदर यहां से मैं फोर्स करूंगा तो क्या होगा, योर डक्टाइल मटेरियल विल कम आउट फ्रॉम दिस डाई ओपनिंग, और आपको क्या मिलेगा, यहाँ से रिक्वायर्ड शेप ऑफ पाइप मिलेगा, हॉलो पाइप मिलेगा, वायर मिलेगी, दैट इज नथिंग बट योर एक्सट्रूजन। समझ में आया ना, क्या है ये, कौन कौन सी प्रोसेस है, क्या बोलते हैं इसको,
मेटल फॉर्म।
हाँ मेटल फॉर्मिंग है, लेकिन स्पेसिफिकली क्या नाम है इसका, एक्सट्रूजन। मैं लिखता हूं इधर नाम, एक्सट्रूजन, व्हाट इज द नेम, एक्सट्रूजन। उसमें दो टाइप है, फॉरवर्ड एक्सट्रूजन, अभी जो मैंने फिगर ड्रॉ की है दैट इज योर फॉरवर्ड एक्सट्रूजन। व्हाई इट इज फॉरवर्ड एक्सट्रूजन, बिकॉज हम फोर्स भी इसी डायरेक्शन में अप्लाई कर रहे हैं और मटेरियल भी इसी डायरेक्शन में बाहर आ रहा है, दैट इज योर फॉरवर्ड एक्सट्रूजन। एंड अनदर टाइप इज व्हाट, बैकवर्ड एक्सट्रूजन। अब बैकवर्ड एक्सट्रूजन में क्या होगा, इस साइड का डाई पूरा क्लोज रहेगा, ओके, इस साइड का डाई पूरा क्लोज रहेगा, और ओपनिंग कहाँ पे दी जाएगी, ओपनिंग कहाँ पे दी जाएगी, यहाँ पे, ठीक है, ओपनिंग यहाँ पे दी जाएगी। तो क्या होगा, हम रैम को फोर्स करेंगे इस डायरेक्शन में, और मटेरियल कहां से बाहर आएगा, यहां से बाहर आएगा। मटेरियल कहां से बाहर आएगा, यहां से बाहर आएगा। दैट इज योर बैकवर्ड एक्सट्रूजन। कौन कौन से टाइप्स है एक्सट्रूजन में, एक है फॉरवर्ड एक्सट्रूजन, दूसरा है बैकवर्ड एक्सट्रूजन। क्या डिफरेंस है फॉरवर्ड एक्सट्रूजन और बैकवर्ड एक्सट्रूजन में, बताओ अभी, रिपीट करो मैंने क्या बोल दिया। In forward extrusion, material is coming out in the same direction of applied force, and in the backward extrusion, material is coming out in the opposite direction of applied force. That is nothing but your forward extrusion and backward extrusion. Please explain what is forward extrusion and what is backward extrusion. Hello, कोई तो बताओ, otherwise I will not stop lecture and I will not take your attendance. If you are attending only for attendance, not able to explain what I have said right now, tell me what is forward extrusion first.
सर फॉरवर्ड एक्सट्रूजन में ओपनिंग राइट साइड में रहता
Not right side में, material is coming out in the same direction as that of applied force. That is nothing but forward extrusion. और backward extrusion में क्या होता है, material is coming out in the opposite direction of applied force. Okay, that is your forward and backward extrusion. Or there is a hot extrusion and cold extrusion. If whatever the metal we are keeping inside, that is called as metal billet, billet. If this metal billet is cold, then that extrusion is called as cold extrusion. If this metal billet is hot, then it is called as hot extrusion. Okay, and if this ram, suppose this ram, okay, if this ram is directly forcing this metal mechanically, it is called as mechanical extrusion. If in between ram and in between this metal billet, if I will use the hydraulics, if I will use the hydraulic oil in between this, then it is called as hydraulic extrusion, right? It is called as hydraulic extrusion. Extrusion समझ में आया सबको? Hello.
Yes, sir.
Yes. Okay. Okay. Recording. Okay. Recording is going on. I will stop the recording.